Today the topic for discussion is numerical differentiation. So first we have to prove some formulae or results. Let us consider the Newton's forward difference formula. This is the forward difference interpolation formula, Newton's forward difference interpolation formula. So what is that? Y or fx is equal to f of a plus hu is equal to f of a plus u delta f of a u minus 1 by 2 factorial delta square f of a u minus 1 u minus 2 u minus divided by 3 factorial delta cube f of a, and then u minus 1 u minus 2 u minus 3 divided by 4 factorial delta raised to 4 f of a. In this way the next term is what? u minus 1 u minus 2 u minus 3 u minus 4 divided by 5 factorial delta raised to 5 f of a. That this a is the first point. Okay, and what is u is x minus a divided by h. What is this? U is x minus first point divided by h. In the forward Newton's forward difference formula, what is the u? U is x minus first point divided by common difference, and in the backward difference formula, it is what? X minus last point divided by h. That is common difference. Okay, and a is the first point, and then what is a value of x from this? If you substitute h from this left side, then it's become uh, and then plus a plus is the value of x. So this is the Newton's forward difference formula. We already learn its proof in the chapter interpolation. Okay, this is the Newton's forward interpolation formula, and we have to prove the formula for numerical integration. So from this what is the next step? This formula in the another notation. So what is the another notations? So suppose this point a, the first point is x naught. These are the another alternate notations for these values of x. X naught, a is denoted by x naught, and f of a is y naught. That is the value corresponds to a of y, or fx is y naught. So we use these notations. So what do we have? Y is equal to f of a. F of a means what? Y naught plus u delta f of a, that is delta y naught. This substitute is f of a as a y naught. So we have this. Okay, so this, and u is what? X minus x naught divided by h, that is a is x naught. So this is the same formula, Newton's forward difference formula in another notations, and u is what? X minus again x naught divided by h, first point divided by. So we use this formula to further prove Newton's forward difference formula. Then that is, this is simplification of this previous formula, that is multiplied by their u, because we have to differentiate this function y. So u square minus u, this is the multiplication of these three bracket is what? This is the u cube minus 3u square plus 2u. This is the multiplication of these three bracket. Then multiplication of these four bracket is this: u raised to 4 minus 6u cube plus 11u square minus 6u divided by 4 factorial delta raised to 4y naught. Again u is what? X minus x naught divided by h. Then differentiate this equation, that this 5.3, with respect to x. With respect to x, then what is the derivative of y? Is dy by dx, and y, this is the function of u, this RHS, and so u chain rule, that is dy by du into du by dx, dy by du into du by dx. And then what is d by what is y? Substitute y as this value. So d by du and y is this value, okay, into du by dx. Du by dx means the derivative of this quantity with respect to x. So what is it? Actually u is what? 1 by h into x minus x naught by h, and the derivative of x naught by h is 0 with respect to x, and the derivative of x by h is 1 by h. So this is the 1 by h. The value of du by dx is what? In the next step it is 1 by h. That is the derivative of this u with respect to h is this 1 by h, and this dy by du, that is d by du of y means this quantity. So write this quantity, and then its derivative is what? The derivative of y naught with respect to u is 0. because y naught is constant with respect to u, and the derivative of u is u square by 2. U square by 2, not u square by, it is integration. The derivative of u is 1 with respect to u, and so delta y naught. The first term is what? The derivative of u is 1, and that's about delta y naught. Then derivative of u square is 2u. Derivative of minus u is 1 divided by 2 factorial delta square y naught, and the derivative of this u cube is 3u square minus 6u plus 2 divided by 3 factorial delta cube y naught, and the derivative of this quantity is what? 4u cube minus 6 into 3, that is 18u square, plus 11 into 2, that is 22u minus 6 divided by 4 factorial delta raised to 4 y naught, plus so on, and 1 by h is the value of du by dx. So we have this step, the derivative of y with respect to x, and so we can write this in this form. That is, take this 1 by h as the first quantity, 1 by h in bracket delta y naught 2u by 2 factorial delta square y naught, this quantity 2u minus 1 by 2 factorial delta square y naught, and the remaining factors. Here is right delta raised to 4 y naught. Here write delta raised to 4 y naught. This term delta raised to 4 y naught. This is missing at this place. So correct here that this bracket 4u cube minus 18u square plus 22u minus 6 4 factorial delta raised to 4 y naught. So right here delta raised to 4 y naught plus so on. So this is what? Dy by dx, that is the derivative of y with respect to x. Then at x is equal to x naught, what happen? U is 0. At x is equal to x naught, if you substitute x is equal to x naught, then x naught minus x naught is 0, that is u is 0. At x is equal to x naught, u is 0. That is, substitute u is 0 at this place in this equation. What do we have? Dy by dx at first point. At x is equal to x naught is what? 1 by h delta y naught minus 1 half. Substitute u as 0. So minus 1 by 2 factorial means 1 half delta square y naught. Then substitute u as 0. 2 by 6. 3 factorial means 6. 2 by 6 is 1 by 3. 1 by 3 delta cube y naught, and the value of u is 0. Then we have minus 6 by 4 factorial. That is minus 1 by 4 delta raised to 4 y naught. Delta raised to 4 y naught. And in this way, if you find further terms, then the next term is plus 1 by 5 delta raised to 5 y naught minus 1 by 6 delta raised to 6 y naught. So this is the first order derivative of y at point x naught, at first point. So remember this formula. Then second order derivative, that is the differentiate with this dy by dx again with respect to x. Then what do we have? D square y by dx square is 1 by h, again 1 by h, this 1 by h, and the derivative of this quantity with respect to u is x is what? X is what? That is the derivative of this quantity with respect to u into du by dx, because this is the function of u and we have to differentiate with respect to x, means multiply by du by dx by chain rule. Similarly, like this, dy by dx is what? Dy by du into du by dx. That is the derivative with respect to u into du by dx. So what is the derivative with respect to u of this bracket? Derivative of delta y naught is 0 with respect to u. And derivative of 2u is 2 minus 1 derivative 0. 2u by 2 means 2 by 2 means 1 delta square y naught. So this term delta square y naught, this is the derivative of this quantity. Okay, derivative of 2u is 2 minus 1 derivative 0 divided by 2 factor means 2 by 2 is 1. So delta square y naught. Then derivative of this quantity with respect to u is what? 6u minus 6 by 3 factorial delta cube y naught. In this way, the derivative of this quantity with respect to is what? 12u square minus 36u plus 22 by 4 factorial into delta raised to, here is delta raised to 4 y naught, and so on into 1 by h. Du by value of du by dx is what? 1 by h. So we have this term, derivative of this quantity with respect to is this term into du by dx. Again du by dx is what? 1 by h. So 1 by h and this 1 by h become 1 by h square. So this is the second order derivative, general second order derivative. and at the first point, that is d square y by dx square at x naught. So at x naught, x is equal to x naught, then u is 0 like this, and then du square y by dx square is what? X is equal to x naught 1 by h square, 1 by h square, this quantity delta square y naught minus, substitute u at 0. So minus 6 by 6 is minus delta cube y naught. This is the 22 by this 4 factorial, that is 11 by 12 delta raised to 4 y naught. In this way, the next terms, if we find next terms, then that are what? Minus 5 by 6 delta raised to 5 y naught, 1 by 137 by 180 delta raised to 6 y naught. And this is the formula for second order derivative at the first point. This is the first order derivative at the first point. This is the second order derivative at the first point. This is the general derivative at first of first order, and this is the general derivative of this term. This equation is what? The general derivative of the function y second order. The next same proof, if we had to find the differentiation of first order and second order using Newton's backward difference formula. So what is the Newton's backward difference formula? This is the Newton's backward difference formula. Y is equal to yn, that is substitute y naught, replace y naught by yn, and delta by del, and plus sign u minus 1 u minus 2 replaced by plus u plus 1 u plus 2 u plus 3, and this is the backward difference formula. Y is equal to yn means value at last point, u del yn plus u plus 1 by 2 factorial delta square yn plus u plus 1 u plus 2 by 3 factorial delta cube yn, and in this way u plus 1 u plus 2 u plus 3 by 4 factorial del, not delta, del raised to 4 yn, and in this way so on. So u is what? X minus last point divided by h. So this is the Newton's backward difference formula. This is the Newton's forward difference interpolation formula. So here y naught is replaced by yn, delta replaced by del, and u plus 1 u plus 2 u plus 3 replaced by u plus 1 u plus 2 u plus 3, and so on. And u is what? X minus last point divided by h, that is x minus xn divided by h, and then multiply by this u, multiplication of these 3 bracket, multiplication of these 4 terms is at this place, and then u is x minus xn divided by h, and we have to differentiate this with respect to x. So dy by dx is equal to, again, what is the derivative of this quantity? This is the function of u, and so it is derivative is what? By using chain rule, dy by dx is dy by du into du by dx, dy by du into du by dx. So right here dy by du, right here u, here is not the notation x, here is right u, d by du of this quantity into du by dx. By chain rule, dy by dx is what? Dy by du into du by dx. So dy by du, right here u, notation u, so right in at the place of x, write u, and then derivative of this bracket is what? The derivative of yn is 0, derivative of u is 1, so del yn, then 2u plus 1 by 2 factorial del square yn, then 3u square plus 6u plus 2 by 3 factorial del cube y, derivative of this quantity, 4u cube plus 18u square plus 22u plus 6 by 4 factorial del raised to 4 yn. In this way we will find the further terms, and du by dx is what? Is 1 by h. So right here du by dx is 1 by h, and then this is the dy by dx, the first order derivative, then at x is equal to xn, at last point what we have? What is u? U is x minus xn divided by h. So if we substitute x as xn, then what do we have? Xn minus xn is 0, that is u is 0. So at x is equal to xn, u is 0, that is at last point u is 0, and then this equation becomes dy by dx at x is equal to xn is what? 1 by, substitute u as 0 in this equation. So what do we have? 1 by h del yn, 1/2 del square yn plus 1 by 3 del cube yn plus 6 by 4 factorial means 1 by 4 del raised to 4 yn, in this way. Then further terms are what? 1 by 5 del raised to 5yn plus 1 by 6 del raised to 6yn and so on. So this is the first order derivative at the last point. Similarly, the second order derivative at the last point, if we define this, differentiate this equation, then we have the second order, general second order derivative, that is d square y by dx is 1 by s square, and then this is the 0, this is the 1 del square yn, and we have here 2 by 6u plus 6 by 3 factorial del cube yn and so on, and its value at x is equal to xn is what? 1 by s square del square yn, that is substitute in the second order derivative, substitute u as 0, then we get this, that del square yn plus del cube yn plus 11 by 12 del raised to 4 yn plus 5 by 6 del raised to 5 yn, and if you find the further terms, then we also have the further terms. If you find here the fifth difference term, sixth difference term, okay, and the note is what? The proof of the above formulae are not important as far as exam concerned, exam point of view. As the exam point of view, these proofs of these theorems, formulas are not important. So only for this topic, only remember these formulas. So this is the first order derivative. This is the first order derivative. dy by dx, the formula for first order, general first order derivative, general, that is at any point we can find the first order derivative by using this formula, and the second order derivative by using this formula. Already the proof, we observed the proof of these theorems, these formulas, and the derivative at the last point, at the end point, that is, this is the general derivative, this is the note is what? Derivative at point not given in the table. If the point is not given in the table and we have to find the derivative at that point, and the point is at the beginning of table, then use this formulas to find first order derivative and second order derivative. And if the derivative at point not given in the table and at the end of the table, that is, if the point is not given in the table and the point is at the end of the table, then use the formula dy by dx for first order derivative and d square y by dx for second order derivative. And already the proof, we observed the proof of this theorem, these formulas, but the proof is not important as far as the exam concerned. So, and these are the formulae to obtain the derivative at a point given in the table. If the point is given in the table and if the point is at the beginning of the table, then use these two formulas, that is for first order, for the second order. That is x is equal to x naught is the first point. Actually, we can use these formulas to obtain derivative of first order and second order at a point given in the table. If the point is not given in the table and point is at the beginning of the table, then use these formulas. If the point is given in the table, that is, we have to find the derivative at point, and the point is given in the table and the point is at the beginning of the table, then use these two formulas to obtain first order derivative and second order derivative. And use these formulas, two formulas for first order and second order. If the derivative, we have to find the derivative at point given in the table and at the end of the table. So use these two formulas. Okay. So remember these only two formulae. These general formulae are also not so important as far as exam concerned, but these two formulas are important for example and as exam concern. So the first example on the numerical differentiation. So what is the example? Find the first and second derivative of the function tabulated below at the point x is equal to 3.0. That is, we have to find the first and second order derivative by using numerical methods at the first point, at the 3, and that's why we have to use these formulas. That is the derivative at a point given in the table and at the beginning of table. Is the point at the beginning of the table. 3 is at the beginning of the table and given in the table. So we have to find the first and second order derivative at this point. So for this, we have to use these formulas, and here we have observed that it is the increase in the formula are what? Delta y naught, delta square y naught. That is, we have to prepare the forward difference table. So first prepare the forward difference table. So this is the forward difference table. The first column is the values of x, and the second is what? The values of y. Second column. Then delta y, delta square y, delta cube, delta raised to 4, delta raised to 5. And what are the entries? These are the entries, and we know all of you know that how the forward difference table prepared. That is the values of this minus this at this place. Then what is this entry? This minus this at this place, and in this way. What is this entry? This minus this at this place. So we have these values, and these values are important in the forward difference table. These values. This is delta y naught. This is delta y naught. This is y naught. This is x naught. This is y naught. Delta y naught, delta square y naught, delta cube y naught, delta raised to 4 y naught, delta raised to 5 y naught. So write the formula for dy by dx at x is equal to x naught is what? 1 by h, and write the formula up to delta raised to 5 y naught. So this is the formula. Dy by dx at x is equal to x naught is 1 by h, and these terms. So plus minus plus minus plus minus terms, and write up to this delta raised to 5 y naught. So write here 1 by h delta y naught plus 1 half delta square y naught 1 by 3 delta cube y naught minus 1 by 4 plus minus terms up to delta raised to 5 y naught. And h is what? H is 0.2. Here is the difference, 3 to 3.2, difference is 0.2. 3.2 to 3.4, difference is 0.2. So h is what? 0.2, common difference 0.2. X naught is 3.0, that is the first point, 3.0. And then dy by dx at x is equal to 3.0. That is the first order derivative at first point, 3.0 is what? 1 by substitute h, substitute delta y naught. So what is delta y naught? This is the delta y naught. This is delta square y naught, delta cube y naught, and substitute all the values and calculate this addition and subtraction by using calculator. We get answer 9.465. So this is the first order derivative at point 3 at the first point. Then second order derivative at the first point. So write first the derivative formula for second order derivative. D square y by dx at x is equal to x naught. That is this formula. D square y by dx square at x is equal to x naught, and write up to this term. Write up to the terms of order difference fifth. So what are the terms? 1 by h square delta square y naught minus delta cube y naught plus 11 by 12 delta raised to 4 y naught minus 5 by 6 delta raised to 5 y naught. And then substitute h as 0.2, x naught is 3.0, and substitute delta square y naught. Value of delta square y naught is what? This 0.768. Then this is delta cube y naught. What is the delta cube y naught? This is the delta cube y naught. This is the delta raised to 4 y naught. This is delta raised to 5 y naught. Substitute all these values and find the answer. Okay, we get the answer 1.184.375 addition and subtraction of all these numbers. So these are the derivatives of first order and second order at the first point. So if you have to find the first and second derivative at the first point or at the beginning of the table, then use these two formulas. And if you have to find the second order derivative, first and second order derivative at last point or at the end of the table, and but the value given in the table, then use these two formulas. That is, we have to find the first derivative and second derivative at the first point. So these formulas are used for the first problem. Similarly, we will solve these remaining problems in the next lecture.